Donna Taylor here. In this video, I'm going to explain what capillary electrophoresis is and how it works. But first, my thesis. Capillary electrophoresis is a more powerful separation technique that often exhibits higher resolution and shorter analysis time than agarose gel electrophoresis. CE is the fastest, most cost-effective methodology to detect LD isoenzymes. Capillary electrophoresis. What is it and how does it separate LD isoenzymes? Electrophoresis may be defined as the migration of charged particles through a solution under the influence of an external electrical field. Capillary electrophoresis operates as an amphoteric separator capable of separating isoenzyme molecules such as lactate dehydrogenase isoenzyme, thus allowing isoenzyme identification. The schematics show us capillary electrophoresis instrumentation. In capillary electrophoresis separation is performed in narrow-bore fused silica tubes with an inner diameter of about 2,575 millimeters. Usually, the capillaries are filled only with buffer, although gel media can be used. The following is a schematic of a CE instrument. Initially, the capillary is filled with buffer, and the sample is loaded, applying an electric field, performing the separation. Detection can be made directly through the capillary wall. So detection can be made right here. A cross-section of a capillary tube. LD. Serum or serum isoenzyme patterns of LD, along with CK, in patients suspected of acute myocardial infarction has become a highly sensitive and specific diagnostic method. LD isoenzyme separation using CE. 1. Create a positively charged coating. 2. Immobilize the enzyme. 3. Inject the substrate. 4. Apply voltage. And 5. Wait for results. LD patterns after electrophoresis. Electro-osmotic flow, or EOF. A fundamental concept in CE is electro-osmotic flow. EOF is a bulk flow of liquid towards the cathode. Upon application of electrical field, and it is superimposed on electrophoretic migration, EOF solutes remain in the capillary. Cations migrate fastest because both EOF and electrophoretic attraction are towards the anode. Neutral molecules are all carried by the EOF. Why perform LD isoenzyme? The main advantage to perform LD isoenzyme is separation is to aid in the detection of those infarcts that have occurred more than 5 days before enzyme analysis. Because of the many conditions that contribute to its increased activity, an elevated total LD value is rather nonspecific. LD assays, therefore, assume more significance when separated into isoenzyme fractions. The following chart shows LD isoenzymes after separation: LD1, LD2, LD3, LD4, and LD5. In the serum of healthy individuals, the major isoenzyme fractions is LD2. Therefore, in conditions involving cardiac necrosis, the serum levels of LD1 will increase to a point at which they are present in greater concentration than LD2, resulting in a condition known as the LD flipped pattern. Errors. Pre-analytical. Hemolysis. Erythrocytes contain an LD concentration approximately 100 to 150 times that found in serum. Therefore, any degree of hemolysis should be rendered a sample unacceptable for analysis. Analytical errors. The pH in a capillary can be affected, countering the stacking effect. Ionic strength, large volume, too much analyte can also create analytical errors. Advantages. The narrow tubes gives capillary electrophoresis good resolution, excellent lateral flow, and a constant velocity, and reduces band broadening seen in peaks generated in other techniques. Disadvantages. Protein separation tends to absorb strongly to the silica surface, thus distorting the separation and affecting resolution. Inadequate LODs. pH in the capillary can be affected during stacking, and efficiency is limited by lamellar flow. Conclusion. When diagnosing AMI, utilizing LD isoenzyme CE maintains a more versatile technique in a clinical laboratory when compared to agarose gel or even HPLC. In conclusion, the above table indicates that CE can shorten the turnaround time of LD isoenzyme tests in a clinical lab when compared to conventional agarose gel.